Hi everyone, in this video we're gonna take a look at how um, autoencoders work. So the main idea is you give it an image as an input to the encoder, then the encoder will reduce further and further the dimension of the input. So let's say we have 10,000 pixels, then it will pass in 10,000 neurons in the first layer of encoder, then in let's say 100, then let's say in 2. So we transform this 1,000 dimensions into only 2 dimensions like this. Uh, so let's say, for example, it can encode, I don't know, the fact that it's a house and the position of the house. Maybe it's 2 neuron. And then, so this is called the bottleneck. And then we have a decoder that will try to, from the information we have in the 2 neurons, try to restitute as close as possible the original image. So it only knows it's a house and where it's placed on the screen. So um, we come from 2 neurons to 100 and then to 10,000. So this will be the output pixels. And one thing that is important is that the encoder and decoder needs to be symmetrized. It's just a mirror. If it's not a mirror, you will have bad performances. And so basically the decoder outputs, for example, this image. And as you can see, both are houses, but not exactly the same. So the idea is that the autoencoder auto-encoded the IDs on the image. It it encoded the idea that it's a house and it's centered. So let's say, for example, um, I take the house and I put it in the corner, for example, top top left. Then maybe if the first neuron here is encoding the fact that it's a house and the second the position, so the first will normally stay the same compared to previously, and the second one will change and now saying that the position is top left. So when we will run the decoder, normally we should have a house, but now in the corner. And you will say, oh, so what's the point of a autoencoder? We started from a house, we get a house, who cares? What it allows us to do is, for example, we can uh, take images. If we want to make, for example, a denoiser, so we have an image with a lot of, for example, small dots, small dots everywhere. It's very noisy. I don't know. The light conditions were bad, and the image is very degraded, and we want to restore it to its original shape. So what we can do is, to train the model, is to take images that have no issues. Let's clean this mess. It has no issues, and we add ourselves the issues. So we make an algorithm that puts random dots in the image. So this is clean, this is noisy, and we train the model to try to output the final image and to train the model to know how we need to change the weight. We compare not this one to this one, but this one to this one. And by comparing, we basically train the model to put a noisy image and output a non-noisy image. And for example, I don't know if you know Blender. Blender, oh, Blender. It's an software that allows to do 3D renders. But usually we have to do it in ray trace mode, and we have at the end an image with a lot of noise. And but when you go online and you watch movies made with Blender, there is no noise. How does they manage to do it? It's basically with this auto encoder system. So this is the base version, but it has some limitations. So that's why we have created the VAE, variable autoencoder, that introduce a beta variable that will basically say how well we need to stick to the base ID. And yeah, I hope you find this video helpful.